break it down for you. At least this should help you start your simple shell project if not started at all. And I'm gonna need you guys to pay attention a little bit, just so that we can do something today. Alright? So you're about to create a simple shell, meaning that you have to know what a shell is. Okay? If you guys are started and encountering challenges, then I can handle those challenges specifically. But right now I just have to be a little generic just to start you off. Okay? You already know what the shell is. It's a program that takes command input written from the user's keyboard, passes them to the machine. Let me not even worry myself reading. Rather, let's get practical with it. So I'm just gonna open my terminal. Okay. Then, so this interface you see over here is what is known as the shell. Okay. Take note of this. You're realizing that there's this blinking thing here. That is what is known as the prompt. So this dollar sign you are seeing over here is what is known as the prompt. Whatever you open your shell, this is your shell, you're gonna see a prompt. So the first thing you're gonna do in creating a shell is creating this prompt. It is always there. When I enter, it will come up again. When I enter, it will come up again. This prompt is always there. It never disappears. And that is a very important feature you need to know in creating your own shell. Right? So I was saying that the shell is a command line interface that acts as an intermediary between the user and the operating system. Its primary function is to interpret and execute user commands. The inner workings of a shell can be quite intricate, but here is a high-level overview of how it works. So you need to know how the shell works, and that's what I'm about to break it down for you. That's what I'm about to break down for you. The other meeting that we had, I was explaining this diagram to you, and I was telling you guys that every operating system has a component known as the kernel, and this is what receives commands from the shell and executes them. And as part of the kernel are what's known as system calls. Okay, so the shell is going to rely on system calls to create itself. And then system calls are functions. They are not necessarily they are different from functions. Functions are self-contained block of codes, but system calls are part of the kernel. You're going to understand them in a bit, in a moment. So the shell you are going to create will rely or communicate with the kernel. So you're going to realize that when you enter a human language command in a shell, it converts it to binary language, and the kernel understands binary language and gives an output back to the shell. So in here, when I type ls, I'm going to get an output, a list of files. Let me clear my screen. Or pwd, it gives me some output, meaning that between this command and this output, some binary conversion has gone on under the hood. And that is what the shell is, basically. Very simple. So how does it work? Okay, and this is what is going to let you know how to create your own shell. How the shell, when you know how the shell works, I gotta admit somebody, give me a moment. When you know how the shell works under the hood, that is what is going to help you create your own shell. The first thing that the shell does, like I was telling you, is that it displays a prompt. Very simple. When you open a terminal and you start the shell displays a prompt indicating that it's ready to accept commands. The prompt usually includes information about the user host, blah blah blah. So for instance, here in my shell, you can see that this is my username Moonspeed, and this is the prompt. If let's say I cd into um, any directory, let's say anything, flags notes, you're gonna realize that I have my current directory displayed over here. And this is for GitHub. It means I'm on the main branch. This is a GitHub repository, but you don't have to worry about that. I'm gonna cd out of here. Yes. So the first thing that the shell does is that it it has a prompt that is ever ready to receive commands. That is very simple, and you are going to need to implement that. And the next thing it does is that it reads user input. So just like you saw, I give input to my shell and it gives me an output. How do you receive user input? Use the function fgets. Keep this in your mind. Fgets. Let me make it big. Use the function fgets to receive user input. Very simple. Then what else does the shell do? When the input enters the shell, what the shell does is that it parses the command you have given to it. So the shell is going to parse the user input to understand the command and its argument. I'll explain what that means to you. Then it's going to split the input into tokens. This is where something known as tokenization comes in. I'm going to explain what tokenization means to you in a bit. So for instance, if I say something like my name is Leo, okay? What is happening here is that this is one string, which is one statement, one string, all right? So what tokenization means is that the shell is going to take, let's say, this string or statement I've given as a command, and it's going to break it down into single argument. So the shell is going to do something like my name is Leo. So this is what we refer to as tokenization. You have to implement that in creating your shell. I'm going to show you how to do it. So if you realize this statement, you're going to see that everyone is separated. Every one of them is separated by a space. Okay. So I can tell my shell that anytime you encounter a space, consider the entire word as an argument. So in this case, whenever the shell encounters a space, it will consider the entire word as one argument. So this is a space and this is a space. This is a space too. Okay, so when the shell is going to tokenize this command, it's going to break it down by the space. Okay, and that space in there is what is known as a delimiter. A delimiter. Delimiter. Okay, that's what you see over there. A delimiter. All these I'm saying are quite important. Someone wants to join in. You guys see the reason why I usually like someone else to set up the call, because I have to keep admitting people in. Right, I think we're good. Okay, so then the next thing the shell does is that it's going to search for the command that you have given to it. So once the command and its arguments are parsed in printf, if you guys remember, I taught you guys about string parsing, parsing. Okay, parsing. So what string parsing is that the shell or the compiler is going to take it character by character. It will take B and check, is it a special character? No, it's not. Then to write it to standard output. A, it will do the same for all the characters in here. And then when it checks all of them are usual characters, you just write it straight to the standard output. So you're going to see it on your screen. So if I echo, let's say in my shell, if I echo my name, let's say Leo, it's going to give me an output of Leo, because this Leo that I give to my shell has no special characters. All right, but then if I probably give it some special character, let's say I echo, let me echo, let's say asterisk dot whatever, let's say Jason or whatever, and you see that suddenly I have a different file over here. That's because now the shell is considering special characters after string parsing. So what the shell did was that it came to check each of the characters, and then it encountered special characters, for which reason it knew what to do. And this time around, it knew that I was not just trying to echo my name. I was giving it some particular command. So it needed to check it character by character, encounter a certain special character, and give me another output. All right. So that is what string parsing is about. Yeah, that's what we're gonna keep doing today. We'll keep admitting people. All right. So the shell is gonna search for the command and parse the command you are giving to it. Then it will look for executable files corresponding to the command. Okay. Then when it finds that executable file, it's going to execute it. I'm going to explain what that means to you. Okay, so let me show you over here. This is my operating system. This is my system. I'm going to take you into it. Let's view it as columns. Very good. In every right, let's first view it as an icon, okay, so that I can explain something to you. Like I explained to you guys the last time, in every Linux operating system, there is only one foundational folder. As for this, it's just the network. That's what gives my computer internet connectivity. So it doesn't even mean anything. But this hard disk or drive you see over here is the thing that contains every operating system file or user created file in the Linux operating system. So when I open my root right now, these are the folders in there. But just like I explained to you guys the other day, there are hidden folders in here still. So when I make my hidden folder show, we're gonna see that there were several folders in here that were actually hidden folders, which the system has hidden because they are executable files. All right. Today is today. Okay. Now there is a special file in here known as the binary folder, which is usually referred to as bin. So if you look at this one, you're gonna see that you're gonna see a folder known as bin. When I open this bin, it contains so many files, which are all executable files. Yeah. So what the shell does is that, let's say if you look at these files, just like I was explaining to you guys the other day, you realize that they contain names you are familiar with. Look at this: rmdir, remove directory. This is rm, this is pwd. So the commands that you have actually been entering into your shell, they are not just commands, they are actually files. These files are executable files. Okay, so for instance, if I enter pwd over here in my shell, this pwd searched for an executable file known as pwd, and then it executed it for me. If I enter, let's say, cal, okay, and I enter, it displays a calendar because this cal is actually a file in my operating system, and it's an executable file. So when I give it to my shell immediately executes it. Okay, so now what you're going to do is that the shell that you are about to create will also search for files, custom executable files in your code base, and then it's going to execute those files whenever you give a certain command. So the file that your shell will execute will depend on the command that you give to the shell. So over here I'm saying that once the command and its arguments are passed, the shell searches for executable file corresponding to the command. Listen to it carefully. The shell will search for the executable file corresponding to the command. It looks for the executable file in directories specified by the path environment variable. We'll talk about that. So let's say if I enter a command ls in here, the moment I enter that command, my shell comes into this binary directory and looks for the command ls and then executes it. So this is the ls file you see over here. It's an executable file. Now let's view it as columns so you have a fair idea of what's going on here. This is the root. This is the binary folder. Where is the binary folder? Bin. Here is it. Then inside that binary folder, you can see that it has all these files. This is what is known as the environment. Okay, this is the path. So our path is from the root to the bin to the executable files. Now I need you to hear this carefully. That is how you're going to code. This is what is known as the path. P-A-T-H, capital path. Usually it's spelled in capital letters. So assuming I wanted the path to, let's say, PWD. I wanted the path to PWD. I'm going to move from the root. I've said this over and over and over and over and over 1,000 times that the root is represented by /. So let me make this a little bigger. So I'm going to move from the root, which is /. Then from the root, I'm going to come into the binary folder, bin, which is this is the folder bin. Okay. So from the root, which is the /, and I'm going to come into bin. Then from bin, I'm going to go to the file known as, let's say, ls. Okay. So I'm going to move from bin ls. So this you are seeing over here is the path to the executable file known as ls. Assuming I wanted to execute the file known as bash. Okay. Now I'm going to move from the root to the binary folder to the bash folder, which is an executable file. So the path is going to be the root first. This is the root. Then this is the binary folder. Then what file am I trying to execute? Bash. So this is bin bash. you guys remember that in ALX, whenever they say write a script that does something, immediately you're going to start with bin bash. Usually it's going to be the shebang, so um, hashtag, then exclamation mark, bin bash. Usually this is how you write it, and it's very simple actually. So the bin bash that you've been writing, bin bash, is actually a path to the bash file. Okay, so you are trying to tell your operating system that this file that I'm about to execute, follow this path, move from the root, go to the bin folder, then go to the bash file, and then execute it. So this is what is known as the path. The path, and you have to understand that, and it's very, very important in determining how your shell is going to travel into your code base. I'll hear this carefully. Your shell is going to travel, whatever command you give to your shell, it is going to travel through the code base all the way to the executable, where the executable file is hiding. That is very important. So that is what is known as the path. And most of the executable files for your shell are usually in the bin directory. So everything you see here are shell commands. Okay. Then the next thing that the shell does is that it's going to create a child process. In the first meeting that I had with you guys, that before I disappeared to go and handle my own things, I was talking to you guys about the PID, PPID, fork, and all those processes. I'm not gonna go back to that, but I'll at least give you a fair idea of all that. When I'll summarize all this process too, because I have to rush through it a little bit. When your shell is done executing, searching for the command that you give to it and finds the executable file, it is now going to create a baby process of the parent process of the main shell. Okay, so let me go back to the practicals. I'm about to give my shell a command. I'm going to give my shell a command pwd. Okay, remember that this shell itself is a session that I'm running. Let me get somebody in. All right, remember that this shell I'm running itself is a session. Let me open a new shell. You're gonna see something. I just opened a new shell. Okay, so this is the one I was on, and this is the new one. Now, whenever I open a shell, it started a new session. Okay, so I logged in Thursday 17th August 8:46 my time. Okay, then all these are personal configurations that I myself was trying to work on in my own shell. So don't worry about all what you see over here. But what I want you to focus on right now is that when you start opening your shell, you have opened a shell session. That shell session is what is known as the parent process. Okay, it is known as the parent process. When I enter, let's say, a command ls in here, that ls I'm about to execute is going to become the child process. Or if I enter a command pwd, whatever command I'm giving to my shell is going to become the child process. So when I'm executing the child process, the parent process has to wait. When the child is done executing, the parent process will take over again. Okay, so I'm about to execute pwd. I now enter. The execution of this command happened in milliseconds. It was so fast you didn't even realize something happened. Okay, however, this that I just did was a sub process of this shell session process. So this entire shell session process is known as a parent process, and this small one that I did over here is what is known as the child process. And just like I was explaining to you guys the first time, you have to I'll make the video public again. I mean, you guys really need it. And then um, the one that I just did over here is what is known as the child or baby process, and it has a process ID. Everything you are doing on your computer has a process ID, just like I was explaining to you guys in the first video. Okay, so now what your shell is going to do is that I've given it the command ls. It's going to create a child process to execute that ls command. When it is done executing the ls command, then the parent process will take over again. Okay, so what happens is that this prompt, let me try and execute something that will take a while to execute, so that you see that the prompt will have to wait. This prompt you are seeing over here would have to wait for the child process to finish executing before the parent process takes over again. Okay, so let me try and execute anything. What can I execute that will take some time? Let me not worry about that. It's gonna waste time. But I guess you guys like have a fair idea of what I'm trying to explain. Do you guys understand what I was trying to say? Can I get some feedback? Is it? Do you guys hear? Okay, yeah, yeah, great. Now, when your shell has created a child process, it will now execute that command. Okay, and it's going to use the exec function to execute the child process command. Okay. Now, the child process is going to be created with a fork function. All right. The execution is going to be done with the exec function. Then we're going to use the wait function to cause the parent process to wait for the child to finish executing. If you don't understand all these things, don't worry. I'm going to explain it to you. Then, when all this is done, we're going to return the prompt again. So let me minimize this and let's see the entire process of the shell. How the shell works. First, the shell is going to display the prompt. Number one, display prompt. Okay, so our prompt is displayed. One. Number two, read user input. So you know that you are going to need a function. Now we are about to code the shell for real. Okay, you're going to need a function to display the prompt. Very necessary. So this is the prompt we have displayed. When I enter, the prompt will come up again. So in your mind, you should know that this is something that is always occurring. Right over there, you know that this is going to be an infinite loop, either an infinite for loop or an infinite while loop. To be able to create a process like this, where the prompt is always executing, it's like it's always waiting for a command. The only way by which you can do something like this is an infinite loop. It's always ready to execute. Okay, that is very important. Then the next thing you're going to create is that you're going to need a user input function. So a function, we're also going to create a function that will read user input. Then we are also going to create a function that will pass the command. That is the tokenization I was talking to you about. So you are going to need a function that will tokenize the command, whatever you're passing to your shell. So let's say I pass a command to my shell like ls-l. Okay. First, the shell will read this ls, then come and read the argument of the ls. Usually, when tokenizing, the first word is always the command, then the rest are arguments to the same command. So I give my shell ls-l and enter, it gives me a certain output, right? Then, the next thing we are going to do is that we are going to need, we're also going to need, as for the section of the command, the shell is going to do it on its own. But later on, when you're doing the advanced tasks, you need to handle the environment variable. But fortunately, for the beginning tasks, they don't even require all that. Then to create that child process to execute your command, you're going to need a function fork. Then to execute a command, you're going to need a function exec, either exec clp or exec ve or any of the exec family of functions. So you see, the reason why coding the shell has become difficult for many of you guys is that you don't have the foundational knowledge of these processes. Process management, fork. You have to take your time, go and understand process management, how the exec functions work, how to parse a string, how to read user input, then control structures like while loop, infinite loop. These are the foundations that you need. And the wait function is also part of process management. So we're going to use the wait or wait PID to cause the parent process to wait for the child to finish executing. Okay. Then when we are done, we'll display an output. How do you display an output? Simply put, you can use printf. If I want to display an output in a C program, the one that we usually use is printf. So if I printf something to my output, whatever I print to it, this is not a C program, so it's going to give me an error. But you get what I mean. So if I want to print something to my screen or to the standard output, I'm definitely going to use printf. But here in this project, you're not allowed to use printf, so you're supposed to use the write function. Okay? In the write function, I've explained it over and over and over in past videos. That first, you need to indicate the output stream. Okay? So either the standard input, output, the output stream for the standard output is usually 1. Then you're going to bring the name of your file, or whatever it is. Then when you are done, you allocate the memory. If it is 1 byte, a character, 1 byte. But since you may not know the entire length of a string, you probably might want to use the string length function to calculate the length of your string. So if the name of your string is format or string, whatever you want to call it, so this is how the write function works. Very simple. So with meaning that you also have to go and learn about how the write function works, because you're not going to use printf. You're going to use the write function to be able to output text to the standard output. So under the hood in this shell, when I enter any command, let's say pwd, something is happening under the hood that will give me an output. So the output that I just got over here is coming from a certain function. They are using a certain function to print this output to the screen. That is what is known as the standard output. So you in your function also have to use any of the standard output functions. Here in this case, write, to be able to execute this step. That's displaying the output. When you are done displaying the output, you definitely have to return the prompt, because whenever we are displaying the output, the prompt always comes back. You see, it's back. When you are done displaying the prompt, now you want to exit the shell. So you have to implement a function such that when the user presses Ctrl D, then the shell will exit, or you can use the exit function to exit the shell. This is basically the most basic functionality of the shell that you're going to create, and it's very simple. That is it. So let's get into the code itself. Remember I spoke to you guys about tokenization, where the shell will take the command you're giving to it, the whole statement, and break them down word by word. And that is what is known as the tokenization. And this is the code that is used to tokenize. So you want to take your time, um, um, pause when you get the video. Just take your time, pause the video, and go through this function. It's actually very simple, but we're going to use it in our shell, so I'm not going to explain it right now. If you look at what is going on here, you're going to see something like strtoc. That is what's known as the function to tokenize a string. So you use strtoc to tokenize a string. So here is the preprocessor directive. You guys are already familiar with that. And this is my entry point, int main. This is a data type character, and I'm creating a variable named command. Then this is a string that I want to tokenize. ls-l. This is just an example. It's just an example. It could be anything. Okay, so I could even take it out and say my name is Leo. Okay, then now you want to now start the tokenization process. So you create a variable, a character, string variable. Over here you can call it anything. I'm calling it token. Then remember I spoke to you about the delimiter. You can use any delimiter. So here in this case, the delimiter is a space. Or I could have said my comma name comma is comma Leo comma. So the moment this comma is double, let me get rid of it. So the moment you see a string like this, that means that the delimiter is going to be a comma. I hope you get it. So now you are telling the compiler that when you come across a comma, break the word into two. So my name is Leo. The moment it encounters this comma, it will break. Then name, it encounters this comma, it will break. Is, it encounters this comma, it will break. But assuming it was a space, then the delimiter is going to be a space. But here in this case, it's a comma. Then to tokenize the input itself, you're going to see that the token variable you declared is equal to the string tokenize function. Then you give it the argument. So the argument is the command string. Here is the string. My name is Leo. Okay. So I've given my name is Leo to it. Then I've told the string tokenize function that the delimiter I want you to use is a comma. So whenever you come across a comma, break the word. Then you're going to initiate a while loop and say that while my token is not now, you're going to print the string, and then you give it the variable name. It's actually not difficult at all. So you're going to, when you get the output of this code, you're going to get something like my name is Leo. For now, you don't even have to memorize this code. Just pick it like this and use it. You just have to change your variables for the sake of Kimba. So don't worry. Then there's also something known as the interactive mode and the non-interactive mode of a shell. But we're not going to talk about that right now because you won't need that immediately. Then one more thing before we start the practical coding, there are three main file streams that you need to know of. The standard output, which prints text to the screen or to your terminal, has a value of 1. So the standard output has a value of 1. Then the stream that receives input from your shell has a value of 0. Then the stream that prints error has a value of 2. Just keep it in your mind. We're going to use that. Okay. So now we have GV Jarved our way, all the way trying to understand whatever doesn't even make sense. Let's try and code a simple shell. How do you start? How do you start from scratch? I want to create a simple shell. Now let's start from scratch. Okay. So these are commands you should be familiar with. If you know, you know. If you don't know, you don't know. And if you get it, you get it. If you don't get it, then forget it. Alright? Okay. So here, assuming we want to code a simple shell and we wanted to do these things. Okay, we want to display a prompt and wait for the user to type a command. Okay. Then the command line always ends with a new line. The prompt is displayed again each time the command has been executed. I gotta admit somebody in. Give me a moment. The command lines are simple. No semicolons, no pipes, no redirections, no other advanced features. Assuming we are about to code a shell, okay, but this is how we want to start it. Alright. The command lines are made only of one word. No arguments will be passed to the program. If an executable cannot be found, we're gonna print an error message and display the prompt again. That means that, like I showed you over here, let's say I entered a command which does not exist in the binary folder. Let's say a command like Leo. The shell says command not found because among the executable files in this binary folder, there is no command like Leo. Okay, so the shell we are about to build, the one of the requirements is that if an executable cannot be found, we'll print an error message and display the prompt again. So now I entered a command which was Leo. It could not be found. It told me command not found. Then it displayed the prompt again. So here we go with our prompt. Our prompt must always appear. Okay. Then finally we have to handle errors, and we have to handle the end of file condition. The end of file condition is, let's say, when I'm executing a process, let's say let me see the files that I have in here. I have a file called package.json. Cool. So let's say I want to less package.json. When I enter, now it lists the content of that file for me, but I don't have my prompt back. So you see, my prompt is not here. My prompt is missing. I need to click something to bring my prompt back, and that thing is Control D. Okay, or sometimes on certain systems it's Control C. So the moment I enter that, then that means that I'm going to end my process. For this, I just enter kill, and then I come back to my prompt. Let's say I enter a command like top, which is going to display the processes going on in here. I don't have my prompt. My prompt is missing. Okay, so I need to get back to my prompt, and the command usually to do that is either Q, Control C, or Control D. That is very important. So you're gonna see that they're gonna tell you that handle end of file condition, Control D. Right? You don't have to do all these, at least for the beginning of your shell. Right? What are you gonna need to be able to do this? What are you gonna need? Alright, what will you need to start? Number one, you're going to need a header file. Critical. So you're probably gonna need a header file like usually we have been using main.h, but since we are doing shell, we'll call it shell.h. Okay. Then you're also gonna need a function that will display the prompt. How do you code a function that will display the prompt? Then you're gonna need a function that will read user input. Just like I was telling you, when you enter the input, who will read it? You're gonna need a function that will execute whatever command you are giving to your shell. That is very critical. Okay. Now we are starting the shell. You need to pay attention. You're gonna need a function that will execute the commands you're giving to the shell. Then you're also gonna need an entry point for your shell. So you're gonna need a main source code file that will be an entry point for your shell. Something like main.c or shell.c or whatever you decide to call it. For the sake of Kimba, the thing is that there's so much code on GitHub and the world. as large for simple shell or shell. So if I don't know how the Kimba of ALX executes the plagiarism check, but there are millions of variables that have already been declared in trying to create a shell, and all these variables are descriptive. So there's a high likelihood that your variables will be the same as another person's variables when you're creating your functions in your shell. So I really don't know how Kimba works, and they are definitely not gonna tell us. But then I feel like they should be a little flexible with it, because definitely codes are going to be the same, and they have to be a little flexible with Kimba. Like I said, I don't know how it works, so but for the sake of Kimba, try and be very creative with your variables. Be creative with your functions. I'm gonna show you how the functions look like, because I need to help you start. Alright? But then when you see the code execution of how you are gonna start, be creative with your functions. Maybe um, I'm gonna show you here that I'll use a while loop to start it out, but you may not have to use a while loop. You can probably use a for loop. You're changing the code because you know how to do these things. Or you can use the same while loop. You're going to change the name of your variable. You may want to rearrange your code. Maybe my function that handles the user input is coming first. All right? But then your function that handles the user input, probably you put it at the end. Okay? Or you can even choose to put it in another file and call that function in your main source code file. You guys just hear me out carefully, because for the printf project, the same process, we went through it, and um, at the end of the day, people ended up getting flagged and flagged and flagged and flagged, and I was like, why are you guys getting flagged? I don't understand why you guys are getting flagged, because even if we all learn the same thing and have the same code base, with our ingenuity and intelligence, we shouldn't get flagged, because we can mess around with the code. We can mess around the code, change variables, restructure the code, but it does the same thing. So the reason why I'm giving you guys this advice is that I'm going to show you the code that starts you off with a simple shell. And I expect that all of you are not going to use the same thing. I expect you to get creative with the code and then play with it. Just, you guys know what to do, all right? Okay, so we're going to first, let's create, before we even come to the main source code file, let's talk about the most important file first, which is shell.c. Okay, shell.c. So that's, no, shell.h. Okay, where's my shell.h file? I don't think I wrote it here. No problem. So let's go create it. Let's code. Do I have my VS code here? Hope you guys are with me.
We are here.
Great. I think I was trying to code a certain shell. I mean, it was a while ago. So what did I call it? Simple shell. What? Simple shell? I don't know. Let's see what's in here. It's probably this one. Yeah, I think it could be this one of, I was just trying to code a shell. Yeah, this is one shell I was trying to code. So let's play with this one. Let's play with this one. So assuming we are trying to code a shell, now the first thing you want to do, number one, point one. So let's go. What you need to do, number one, create shell.h. One, very important. This shell.h is gonna contain all your prototypes, your header files, your macros, and everything. And you know that you need to include guard your shell.h. Very critical. You are going to include guarded. You're going to see that if not define shell.h, define shell.h. At the end of the day, you're going to come and say end if. So to include guard your file, the first thing you got to do this, then this. You already know that. Very simple. Then any header file you're going to need is going to come in here. So you need to include standard input output.h. It comes here. Standard library comes here. String.h. Unix standard. So as you go and you're adding more functionality to your shell, then you'll be updating. You're gonna keep updating. You're gonna keep updating over and over and over. But then the very first thing after you create your shell.h, so at this stage we don't have all this. So let me comment it out. We don't have all this. Let me comment it out. Let's get rid of this too. Comment it out. The only thing we have in our shell.h file at this point is our include guard. Okay. Then what are you gonna do next? You have one file now. No. Before even the shell.h, you need to create your readme.md. Very important. So you have created your readme.md, put in whatever you want to put in there. Then the next thing, you have come to create your shell.h file. The next thing you want to do, you want to include guard your shell.h file. Done. Now the next thing you need to do is that go and create your own printf function. Remember that you're not going to, if you use printf in your functions, your codes are not going to check, because printf is usually from the beginning of time, since um, C, hello world, ALX has never allowed us to use printf. I don't even know why they're afraid of printf. It doesn't make any sense to me, because in the real world you can't even write codes without printf, but we are not allowed to use printf, and that's okay, no problem. So you want to create your function that prints to the standard output. Since you're not going to use printf, we need to come up with a function that will allow us to at least execute the functionality of printf. That's the second thing we want to do. So create a print function. Create a print function. 2. Remember that the first thing is your readme. LMD. You already know how to do that. So let's go try and create a print function. So did I do one? Yes, I think I did over here. I'm just trying to mess around with it. Okay, so remember that before you do anything, your shell.h prototype, your shell.h header file must come in every file you create. No doubt about that. So I've included my shell.h, and I'm about to create a function that can print to the standard output. If you look over here, you realize that I'm using the write function. How does the write function work? I've already explained that to you. When you use the write function, first it takes the output stream, and I've already shown you 3 main output streams in C programming. Number 1, there is a standard input, which figure is 0. There is a standard output, which figure is 1, and then there's standard error, which figure is 2. Okay, so for the write function, number 1, you need to indicate the output stream. So the output stream could either be 1, 0, or 2, depending on whether it's the standard input. But this time around, we are writing to the output. Okay, so it's definitely going to be 1. Right? But because we may change it in the future, we are rather going to use a macro. Alright, so instead of saying 1 to represent the standard output, we rather say the standard output file number. And don't try to change don't try to change what you are seeing here. Let's say you say I want to change my variable, so instead of saying standard output file number, I'm going to say standard output file number. No, don't try to change it. This is like a syntax, which is, this is how it has to be. So don't change this one. Then you can change these variables. For instance, I'm creating my own leoprint. I called it leoprint. Alright. Then this is the data type. It's a constant character. Then this is the string. You don't have to call yours a string message. You can call it string. Anything. String. Or you can call it format. Or you can call it my special print function. Just get creative with your functions, people. Get creative with the functions. Alright. So now I've indicated the name, my string. Alright, this where my string is gonna be. Then, like I was explaining to you, the write function, you first indicate the output stream, then the name of your file, or the address of your file, rather. For me, mine, I named it message. And the last thing you want to do is that you allocate the memory. So if it is, let's say, a string of Leo, it has 3 characters, so it's going to be 1, 2, 3 bytes. So here is going to be 3. If it is a string of, let's say, a long string like this, GGGGG. Now I cannot take my time and count 1, 2, 3, 4. No. It's going to waste a lot of time. So what I need to do now is that I'm going to create a function that calculates the length of a string. Okay? So I'm going to say string length. You see? This is a function that calculates the length of a string. strlen. And I'm going to put in my string. I called mine message. So this is the reason why the write function looks this way. This is the string I'm trying to pass to it, but I cannot count. So, and I don't know whichever string I'm going to pass to it in the future. What I'm going to do is that I'll just use a function that calculates the length of a string and pass in the name of my string, so that it will do the calculation of the length for me to allocate the memory. Very simple, very simple. So that is the write function for you. So here in my print function, I'm using the string length to calculate the length of a string to allocate memory. And the reason why I'm doing this is that I'm creating my own custom printf function. So whenever you go into my code, you are going to be seeing leoprint, leoprint, leoprint. Okay, that's because that is my printf function. That is what I am going to be using as printf. So anything I would have used printf, I rather use leoprint, leoprint, leoprint. Remember that we used to do something similar like this for the putchar function. So we create our own putchar function underscore putchar, and now we are using it underscore putchar underscore putchar. Now to use the write function, you need to import a certain header file, and that header file is the Unix standard header file. Now if I come in here, let me go back to my print function. So leoprint, you realize that I have error. It's giving me an error. It's like it has underlined that there's something wrong. And the reason why there's something wrong is that I've not included my header file. So now I'm going to include the needful header files. Number one, I'm going to include, so we are coding, we are making progress. I'm going to include standard input output.h, and I'm going to include standard Unix standard.h so that I can use the write function. Alright, now I've added these to my shell.h file so I can peacefully in my print function use these macros and functions. So you see that the error is suddenly gone. Okay, so the reason why initially I was having an error is because I had not included my header files Unix standard.h, standard input.h, and then I think which one, string.h. Before you use the this function strlen string length function, you also need to include the string.h function. So right there, you know that you have to go into your string.h header file and now include string.h. So I'm going to include string.h. We're making progress, right? Done. So now I've been able to create my own function that I'll be using to print things to the standard output. So third process done. We have created a print function. Now, the next thing you want to do is that create your entry point. Create your entry point. Alright, so I'm going to go into my code. I'm going to create my entry point. Your entry point is going to be your shell.c file. You can call it anything, but it's a .c extension file. So for me, let's say I want to call it shell.c. So this is my entry file. Okay, your entry point file is what's going to contain the main function. The main function. So int main returns 0. Assuming all these were not here, assuming I comment all these out, this is the C structure that you already know. So we are about to create a file in which we are going to evoke our shell, if I can put it that way, right? This is the file through which you are going to evoke your prompt. This prompt, this prompt, this prompt, this one, this dollar sign you are seeing over here. It is this one that you are going to use to evoke it. It is going to be in your main source code file, which I have called shell.c. You can call it anything. All right. So now, how do we even display that prompt? Remember that in our shell that we are trying to create, the first requirement that we are trying to meet says that we should display a prompt and wait for the user to type a command. That's the first thing we are trying to do. How do we do that? So to do that, first you need to create a string, a variable string. Okay, don't worry about this number you are seeing over here. I'm the one who gave it this number. It's like the space that I'm giving to the character string. So I declare the character and I am giving it a space allocation of 128 characters. I can choose anything. Let's say I'll give it 300. 300 is quite too much, but let's say 120. Then this is where the while loop comes in. The while loop I was talking to you about. The reason why the prompt is always there and never goes away because it's an infinite loop. Now I'm going to say that while something is true, one is always one. So it's always going to be true. So while something is true, I don't have to necessarily say while one. I can say that while true, okay. But if I'm going to use this true word, you see that it has given me an error. It's underlying it. It means that I have to include a certain header file, which is the include the standard boolean. Sorry, include the standard boolean. Then I can use true without any. Why is it giving me an error here? Standard bool. Have I spelled it correctly? Just a moment. So let's include standard bool. Oh, okay. I didn't bring the .h. No problem. So before you can say something like this, you need to include the standard boolean header file. And definitely you're not gonna put it here. You're not gonna put it here. Let me take it out. You're gonna put it in your shell.h file. So I'm gonna include the standard boolean.h. Then back in my source code file, I can see that while the condition is always true, or if I don't want to say true, I can say that while one, all right, in C programming, 1 is corresponding to true, 0 is false. So I can say that while 0, what I'm trying to say here is that while false, while it is false, but if I say that while 1, I'm saying that while the condition is always true, because I'm trying to create an infinite loop. So I'm going to say that while true is the same as while 1, they are all the same thing. So while true, display prompt. What is this display prompt? It's a function. This display prompt is a function which you are going to create. That's going to be displaying the prompt. So here in this case, you can either decide that I can write the function that will display the prompt here, or in order to modularize my code, I'm rather going to take this display prompt function and go and put it in another file so that I'll call the function in this source code file. And that's exactly what I am doing here. That, you see, you guys got to get creative. That's what I've been trying to tell you. So you pick my code, or you go to GitHub. You're going to find some code. You're trying to do your simple shop project. You found a certain code on GitHub. There's nothing wrong with that. I don't know what's wrong with our people, but then understand the code, get into the code, understand the code, and start playing with the code. So I'm going to put my display prompt function in another file, but you can choose to carry it, go and come and put it in this source code file. It's your choice. You can do whatever you want to do. So now that I've called this display prompt file over here, function over here, now let's go and write the display prompt function. You can call it anything. I am calling it prompt.t. Okay, so this is the function that will display the prompt. Careful, hear me out. Hear me out. This is the function that will display the prompt. So I've created another file and I've called it prompt.t. Call it whatever you want. And inside that file, definitely I've included my shell.h. Then I am about to create the function. It is a void function. Note that. Then this is the name of my function. I called it display front. You can call it whatever. You can call it whatever. Call it whatever. You can call it the ever abiding prompts. Okay? I call it the ever abiding prompt, but I mean that's like a funny name, but that's not how I called mine. Okay, I called it display prompt. Okay, then it doesn't take any parameters, right? So it's void. Then remember the print function that I'm going to create. The print function I created, that is what I'm going to use to display the prompt. So originally, assuming we're allowed to use printf, this one would have just been printf Leo shell. Simple. Life is very simple. It would have been simple. But because printf is not part of the functions I can use for this shell, I use my own custom Leo print function, which I want to create over here. Okay, Leo print. This is it. We use the write function, remember, to create this Leo print function that will print to the standard output. Then now in my prompt.c file, I'm using that Leo print function to print something to the standard output. What am I printing? I'm printing Leo shell. So now in this shell, what is displayed over here is just a dollar sign. It's just a dollar sign, okay? But then in my shell that I am creating, when I am done and then I evoke my shell, this dollar sign is not just gonna be a dollar sign. It will say something like Leo shell, just Leo shell, okay? Leo shell, just like I've put in my code. So this is a prompt that will be displayed on my shell, right? It's very simple. So if you're able to do this alone, you've handled the first task, okay? So now that I've created another function called display prompt, what will I do? I'm going to carry the prototype of this function. Every function I create, the prototype is going to go into shell.h, right? So immediately you know that I'll come into my shell.h file and I'll include my function display prompt. See, we are coding, we are making progress. I hope you guys are following. So I've come to include my display prompt function in my shell.h, okay? We are making progress. Then now, where am I? Okay, so I'm going to go back to my files. Great. So I'll go back into my prompt.c file. Great. That's what I was trying to explain to you guys. So now I've created a function that will display the prompt, but I'm not done. I've created a function that will display the prompt, but I'm not done, because even though this prompt will be displayed, what is going to execute the process? Yes, I've created a function that can display the prompt, but the function is like, it's there, but it cannot be executed. I don't even know how to explain what I'm trying. The function cannot be executed by my shell I'm trying to create. So I need to go and create another function that can execute this shell or this process to display the prompt. So that is the next thing I want to do in creating my own shell. The next thing I'm going to do is I'm going to create a function that can execute the prompts. You get it? Very simple. Very, very simple. So let's go create a function that can execute the prompt. Then, where I can call it anything. Let's say, let me just comment all this out. Minimize it a bit. See what's going on here. So I'm gonna comment all these out. So let's create a function that can execute the prompt. How do you create such a function? It's very simple. This is what I was trying to do here. Great. How will you do it? First, sorry. The first thing you gotta do is that definitely, as usual, include your shell.h. Definitely. Then you're gonna create a function. I am calling my function execute command, because in my mind that's what's gonna be executing the commands. What parameters is this function gonna take? It's just gonna take a string. It's gonna take a string. Very simple. It's gonna take a string. Remember that in my shell, whatever I'm typing in here as commands into my shell is always executing strings. So you see, these are strings. So the parameter that the process is gonna take is a string. So that's why I have the constant character over here. Then, just a moment, I gotta admit somebody in. I thought I had to. Wait, someone has raised their hand. Okay, go ahead. Go ahead and ask any question before I continue.
Yeah. Please, I just wanted to know if you are recording a session.
Am I recording this session? I don't think I'm recording the session. All right. Oh, I think I am. Oh, I think I'm recording the session. Don't worry. Yeah, I am. I'll make it available for you guys. Okay. So even if I'm not recording the session, at least what I'm saying, um, it gives you a fair idea of how to start. And these are the functions right in your eyes. These are what you are seeing. Play with them, um, edit them, and do your thing. Okay. Okay. So here I'm trying to create. Remember the PID, PPID that I spoke to you guys about like last week. This is where it comes to play. I was telling you that take note of it because you're gonna need it. This is where that PID, PPID, whatever thing. This is at the point where you have to create a function that executes your command, that is when you are going to need those PID, PPID, plenty processes. That is the point we are at now. Okay, so I'm going to create a function that will execute the command. Remember, I'm going back. I keep going back because I want it to get ingrained in your mind. Create your shell.h, create a print function, create your entry point, which is the shell.t or main.t, whatever you want to call it. Now create a function that can execute the prompt. No, if we jump one process, which is create the function that can show the prompt. Show the prompt. Then when you have created a function that can show the prompt, now you want to create a function that can execute the prompt. That's what we are at now. How do you do that? We are going to use functions such as fork, PID underscore t. Remember in the first video I explained to you guys that it's a data type. Just like you have int, char, float, the PID underscore t is a data type that's used to track processes. It's a data type. That is very important. Then the fork is a function that is used to create child processes. Stay with me. Okay, so this is a parent process. The shell process is a parent process. If I do ls, I'm trying to execute a child process. In the background, the thing that was able to execute that child process I gave to it is the function called fork. That's what you see over here. So what is going on here? What am I trying to do here? I am creating a function of return type void because it returns nothing. The name of my function is execute command. The parameter it takes is a string. Then I create a process which is going to be a child process ID. This is a data type. And the child process, I'm using the fork function to create this child process. So my child process equals to create a new process, which is fork. That's all that's going on here. So let me comment my code and say that over here I want to create a child process. Alright. Now this is where the conditionals come in. I'm saying that if my child process is -1, I explained that to you in the first video. If my child process is -1, it means there's an error. So I'm going to use this print error function to say that fork. Then what am I going to do? I'm going to exit the shell. Then the syntax to exit your shell is this exit failure. The reason why it's giving me an error, there's nothing wrong, is because I have not going to include certain system header files. If you don't include certain system header files, you can't use certain macros. So right there, now that I want to execute processes, I need to go into my shell.h file and include certain header files as usual. So I'm going to include my standard library.h. I'm going to include my standard this moment. So I need to include this header file, standard library.h. Let me comment it out. So I've included standard library.h. And there are many more header files that will be coming as we go. So you see that even at this point, we have already included about 5 header files already. Okay, then hold on, I've not included the prototype of my Leo function that I created. So let me include that prototype here. Remember we created a function I can use to print, which I call a Leo print. So I need to come and put a prototype in here. Then now we are creating another function that I can use to execute the child processes, and that is this function. So I need to include a prototype in my shell.h. So this is the execute function I'm creating, and this is the prototype. All right, great. So let's go back to the execute function. Great. Now you realize that after I've gone to include my header files and all that, now I don't have any error in my code anymore. There's no error in my code anymore. Okay, so now I'm saying that if my child process is -1, then exit with an error. This is a syntax for it. Okay, you don't have to change this. It's the same thing. This is like a standard syntax. This is how you exit with an error. Use the function p-error, print error. Right? Then I come and say that if my child process is 0, that means that everything is okay. If my child process is 0, then we are going to execute the child process. Now I need you to pay particular attention here. I need you to pay a lot of attention here. There is a exec family of functions. There is a exec family of functions. All right. So let's go here rather, so that I can write it out freely. There is a function known as the exec family of functions. Exec. Okay? Another exec family of functions, you can find exec VE, exec CLP, exec something VE or so exec VP, something like that. I can't remember all of them offhand. But then all I'm trying to tell you is that there are the exec, all these exec things you're going to be seeing, they are functions that can be used to execute processes. I'm repeating that they are functions that can be used to execute processes. They are functions that can be used to execute processes. All of them can do this work. All of them can do it. However, depending on the one you choose will determine how you implement your code. Depending on the one I don't know, I think ALX is allowing, yeah, they're allowing us to use this particular one. Okay, that's the execv. I'm not too sure. I can't access my internet, so I can't really confirm. But someone should confirm for me whether which of the exec group of functions that will be needed for the. Someone should just confirm for me and let me know so that I know what to do. I'm waiting on you guys. Someone should confirm for me which of the exec group of functions is allowed. Or I should just go ahead and just teach. I should go ahead. It's exec VE. Great. So the thing is that if you're going to use the exec VE function, it means that you have to indicate the entire path when you are doing the advanced task to lead the process to the executable file. Let me explain that again. Let me make it simple. You remember I told you guys that this is the path. So we follow the path through the bin to the executable files. When you are using the exec CLP is actually one of the easiest to use. That's why I have used it here in my code. All right. But then you don't have to use the exec CLP. You can use the exec VE, exec whatever. All of them are powerful functions that can do what you want to do. But then if you're going to use the exec VE, then that means that, just a moment, you're going to use the exec VE. That means that when it comes to the particular task where you have to code the path or the environment, you cannot just indicate the file, the executable. You have to indicate the entire path. So you're going to say something like root / bin / whatever executable. So you're going to say / bin / yeah, that's the root / bin / whatever executable you are trying to refer to. That just this explanation might not make sense to you because I really don't know which example to use for it. But go back. I'm giving you an assignment. Go back. Go to YouTube. Go to Google. All your resources. Go and read about the exec group of functions, and then decide on which one you're going to use. But here, since you're going to use the exec VE, take your time and read about the execution process of the exec VE function, because I'm not going to need it here. You're going to need it for the advanced task or the later task you're going to do. And then you're going to realize that when you're going to use the exec VE VE function, you're going to have to list the entire path to the executable. You understand that much later. Okay, so I'm using exec LP over here to execute my child process. We'll talk about that later. You don't worry. Just give me a moment. Then let me proceed. I'm going to explain. This one over here is very cardinal. That's why I want you to get it. Very cardinal. These 3 lines over here. Then I'm going to go ahead and say that since this child process is executing, the parent process must wait until the child process is done executing before it will take over. That's what I was trying to explain to you guys in the shell. So the shell is the parent process I'm about to execute. This shell process must wait until this ls is done executing. So I execute ls, it's done. Then now the parent process has taken over. So I'm going to execute pwd, child process. The parent process will wait. I've executed pwd, it's done. Now the parent process has taken over. So the parent process must wait. This is what this function is for. So the parent process is going to wait until the child process is done executing. Then the parent process will take over again. In this simple, how many lines of code? 18 lines of code. I've created a function that can execute the processes. As you're coding your shell, you're going to be updating these functions as you go on. But this is how you start. Okay? So we have created another function that can execute a command. We are going to put the function prototype in our main.h. In our shell.h. Very cardinal. So what is the next thing you want to do? We have created created a function that can show the prompt. Now we have created a function that can execute the prompt. What next are we going to do? Finally, before you are done with the first task, you need to create the parsing function, the function that can receive the user input. Very, very cardinal. Okay, so let me just get rid of this. I'm going to comment this out. Remember I spoke to you about the fget function. That's what we're going to use to get the user input. So I'm going to comment all this out rather. Let's work with. All of them can work though, but let's use the one that is consistent with our requirements. So let me get rid of this. Okay. Then let me rather bring this alive. Usually when I'm coding, I like to try various options. Okay. So let's see what is going on here. So create a function that can receive user input. This should probably even come before. Okay, let's bring it. Let's bring it here. So create a function that can receive user input. So we're gonna do that. So now, how do you create a function that can receive a user input? There are various ways of doing it. You use a standard input. Remember, standard input. Use a standard input stream. I'm calling my function read command. Call it whatever you want. Then I'm gonna take my function prototype. What will I do? I'm gonna put it in my shell.h. So I'm gonna create a function that receives user input. I'll put the function prototype in my shell.h. Okay. Then I go back to my user input file and I code it out. So let's code it out. What will I do? I first include my shell.h. Then the name of my function is gonna read command from the user. So I'm calling it read command. Then the parameters of my function are number one, a string. Why? Why is it a string? Because I am receiving a string from the shell. It's a string. What input is the user gonna give me? It's a string. All this is a string. These are commands. They are strings. Okay. These are strings. So my parameter is gonna be a string. Then I need to calculate the size of that string with the size t data type. All right. Size t data type. Then I'm going to use the fget function to receive. The fget function works like scanf. It's the same as scanf, but we can't use scanf here. We can use fget. So that's why I'm using the fget function here. If the next assignment, this assignment number 2, go and read about file input and output. File I/O. File input and output. Then you're going to understand the input functions such as fget, f putchar, f scanf, f blah 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 blah. So you're going to be seeing a lot of f stuff. So you can also see f the one that brings you the standard output. F get string, get s, f get car. There are several functions of the input and output. Make time and then read about them. Watch videos on them. So the function that I'm going to use to receive inputs from the user is fget. So I'm receiving the string. This is the string. You see, that's my parameter. I'm receiving the string. Then also the size of that string. Then I'm using the stream of the standard input. Because this time around I am receiving. Okay. So I'm not going to use a standard output. I'm using a standard input to receive. I'm saying that if my string, all this is now If it is now, then this is a nested if statement. Now watch this carefully. So over here, I'm about to code the shell, write something in my shell. There's nothing. I've not given any input here. When I enter, the prompt comes back to me. That's what we are trying to code. But then when I enter a certain input, then I'll get an output. All right? In my mind, that's what I'm trying to do. So I'm saying that if my string, all this represents my string, this is how the fget function works. These are the parameters that it takes, okay? If my string is now, now remember, this is also very cardinal. You're going to see this EOF over here. It simply means end of file, end of file. One of the requirements that we are going to do for our shell is that we are going to handle the end of file condition. Okay, we are handling the end of file condition. Very critical and cardinal. So I'm going to say that if my string is now, then again, if my end of file into the standard output, listen to this, if my string is now, and if my end of file condition in the standard output, then what I'm going to do is that I'll just print a new line. Listen to it again, it's cardinal. If I don't give my standard input any string, that means it's now, and there is an end of file condition in the standard input, all what I'm going to do is that print a new line. Very simple. So I'm saying here that, let me clear my screen, I have not given my shell any input. The moment I've not given any input to the standard input, that means that there's an end of file condition. So when I enter, print a new line. So we are on a new line. When I enter, print a new line, because there's no input. So if my string is now, there is no input. So what do I want to do? It means that I am at the end of the file condition. If there's no input, you're at the end of the file. There's nothing. What do you want to do? Come back to the next line. So all I want to do is to print a new line. When I enter, I'll always come to a new line. Okay? That's what I'm trying to do over here. So I'm saying that if this condition is true, then all we're going to do is that we'll use our custom print function to just print a new line. Okay? Then we'll exit with success, because there's no error. Even though I didn't give my shell anything, it doesn't mean there's an error. It's just nothing. So I'll exit with the success. There's no error. Everything is okay. Then the next thing I want to do is that I'm going to say that else if this condition is not true, then I want to print an error and exit with a failure. So I'm going to print there's an error while trying to read the input, and I'll exit with failure. Then this function you see over here, I'm sure a lot of you are familiar with it in Betty. What it does is that it removes a new line thing. Okay, so take your time and read about this function you are seeing over here. I think one time Felicia even posted it on the page. She posted something that gets rid of trailing white spaces and new lines when you're trying to debug with Betty. It might have been this one. I've forgotten. Okay, but you take note of this syntax. This function you're seeing over here. So I'm giving my string. So the user input, I'm giving it to this function. All right. Then what it does is that it gets rid of the new line in a string. Why do I have to get rid of a new line in the string? Because over here I'm already printing a new line. So if there's a new line in the string, I cannot print a new line and print a new line again. So I have to remove the new line. I just hope that makes sense to you guys. Hopefully, I hope it does. But then, okay, so now I'm done with the first implementation for my shell. I'm done with the first implementation for my shell. So let's try it out. Let's try and run the shell. Let's see what happens. If you have to debug or if everything is working correctly. So I'm going to cd into the file. Which file am I using? I'm using lsh, right? Okay. So let's cd into lsh. Alright, great. Let me clear my screen. Let's see what's inside here. So we have our readme file. Let's see what's in the readme file. This is my custom shell. The readme will be updated, blah blah blah. That's not bad. I'm gonna update. So let me cut my readme and see what's inside it. This is my custom shell. I'll update it as we proceed. Okay, then we have our custom print file. We have a shell.h which contains prototype. This is an executable file. Gotta get rid of it. So let me remove this executable and remove this executable. Great. And let me ls again. Good. So this is our custom print file. This is our file that executes the function. This is a file that we use to create the prompt. This is our shell.c main source file. This is our shell.h file which contains prototypes, and this is our user input file, the one that takes user input. So let's gcc all these files according to the Wextra Wero. I don't think I have it here. I don't have it offhand. You guys should help me with it. So gcc what Wextra Wero, something like that. Pedantic. I don't remember it. Pedantic.
I think it's GCC
Uh-huh.
hyphen war hyphen war hyphen
Is it capital R-W?
Yes, it is.
Then
Pendatic. That's small letter hyphen pendatic.
hyphen.
Small
Is it pedantic or pendatic? You guys should confirm.
yeah, that's the spelling.
Then what again?
STD
STD.
equals to GM.
G.
Let me
Yeah, confirm so that we have it right. I'm definitely gonna run all my .c files, and I'll probably output it to. Let's call this shell Leo.
I think someone has posted it in there.
Good. So let's call this shell something like basic shell. Let me go see it. Good. Here you are. I have you here. I'm gonna copy it. I'm gonna get rid of all this so that I have it right. So gcc -war pedantic, that's it. And I'm going to try and compile all my C files. Yeah. Uh-huh. Yeah, who's calling me? It's pedantic, right? So it is correct? Is this correct? I should take away the N. Are you sure? Yes, pedantic, yeah, something like this. And let's output this to an executable file. Let's call it Leo. Okay, let's just call it Leo shell. Okay, and I enter. So I'm getting an error. -E-X required when input is from standard input. No such file or directory. Leo shell. Whatever. Oh, you're right. So let me try it again and correct it. So dash O. Okay. Let's execute it again. Okay. So int main void. I have an error here. So there's something in my int main shell.c file. Let's see what the problem is. So int main, I think this open bracket, I didn't close it. Right? No, I didn't rather. Oh, this one. Since great. And then also I didn't call. You remember we created all these functions, but I didn't call them in my main.c file. So we created a read command that receives user input. We created our execute that executes the child process, but I didn't call it in my main function. So what you want to do after you have created all those functions, that you are supposed to come into your main source file, call all those functions in a while loop. Now hear me out. Call all those functions in a while loop. That's critical. So that's where my error is coming from. So I'm going to compile again. So gcc-o-pedantic.c-o to leo.shell. Then it works perfectly. So I'm going to ls and see my executable. Where is my executable? What did I call it? I called it Leo shell. So I'm going to try and execute this Leo shell and see what I get. I enter. Do you see what's happening now? So my prompt is active now. So I have another. Initially, my username is Moonspeed. Okay, my username is Moonspeed, but right now I've evoked another shell, and this shell that's working is called the Leo shell, because that is what I called it in my prompt when I created the what is that one? My prompt.t, right? Yes, I called it Leo shell. So assuming I change the name over here, that's what will be displayed. So let me increase the dollar because I have a lot of money. I'll save it. And I'm going to clear my screen. Let me first exit the processor pressing Control D. Alright, let's just get rid of this. Exit. Let's get out of here. I actually created two terminals, unfortunately, instead. How do I just close this, close this, close this? Good job. So I'm going to compile again and enter, execute my Leo shell. And you see that suddenly the prompt is showing again. So when I enter, it's going to keep showing me this prompt because it's a while loop. I'm going to enter. And if you look at here, you're going to be seeing no search file or directory. Look into your intranet. You're going to realize that in the gray box entry, you're also going to be seeing no search file or directory, no search file or directory. Every command that you give to it, it will tell you no search file or directory, no search file. Why is it that there's no search file or directory? Because in this particular shell that we have created, we have not given it any environment variables. There's no path, there's no redirection, there's it's just like a basic shell because that's the first thing we are supposed to do. uh, the instructions were to do what, just to implement um, something that just prints a prompt. We are not even using the path, we are not using built-ins, we are not using special characters, we can't even move the cursor, we are not even handling arguments, no argument. That means that the tokenization that I even spoke to you about, we have not even tokenized our argument yet. And that will be the next task that you're required to do. You're supposed to tokenize your argument. So that is where now if you give your shell multiple line commands, then the tokenization is going to come in. You tokenize each word and then move to the next word, move to the next word, put all of them together as one command and let the execute the function that's supposed to execute the process execute everything. I'm going to show you how to do that right now because I've actually written it out. I was trying to code it out. So for the first thing we are supposed to do, we have passed our first requirement. But you guys should remember that this code is not compliant with Betty. This code is not compliant with Betty. So if I run it in a checker, it's not going to work. But you guys know how to do Betty compliant code. For instance, in this file, I can't just come here and write all these things. No, I need to comment everything according to the Betty guideline. So I'm going to do something like this. According to Betty, you do something like this. I do this. Comment. So everything is supposed to be commented. So I'm going to say something like these are blah 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 my header files. Then I'll come in over here and comment again, full of just sparse your things with comments. I'll come here and say something like um, um, these are my prototypes, blah 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 blah. Then whatever I'm gonna put in my shell.h file is intersperse them with comments because that's the better requirement. And then even in the main source files, there should be, according to Betty, you're supposed to put a comment here. So you go something like Betty comment, something like that. You already know what to do. So just do just like a skeleton. It's a skeleton, a working skeleton that you just need to work with. Go into your files, make them Betty compliant. But then when you are able to do the first step, at least you have a working prompt. You're going to be seeing no search file directory, but your prompt is active now. What do you want to do next? Now you want to handle, the next thing you want to do is to handle arguments. All right. And what are arguments? Let's say I come into my shell. Let me open a new shell. Now open a new shell. If I enter one command like let's say get is one command, but I can enter get add. The add becomes an argument. I can even say get add the current directory, or I can get add the entire path. Let's say from root to user to moon speed to a certain file that I have in my system, blah 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 blah. So all these additional things that I'm giving to the first command get, the additional commands are called arguments. So assuming I say ls, the ls is a command. But if I say ls dash a, that's an argument. It's a flag. Or I can say ls dash a dash l. I'm listing hidden files in a long format, or any argument at all. So the additional argument that comes in are what will cause you to now bring in the code that will tokenize your string. Okay, so assuming now I want to solve the second task. Okay, so I now need to come into my executable function and update it and edit it. Okay, so I'll go into my executable function, the one that creates the child process, and I'm going to update it to be able to tokenize the string, the command. Remember that this is the string. This is a string. I have to be able to tokenize it if it is not just one word. Because for the first requirement, we are only supposed to handle one word prompts, which is, where is it? The command lines are simple, no semicolon, no pipes, nothing, nothing, nothing. No arguments we pass. You see, there are no arguments. The commands are only made for one word. See? And even if you enter any word, it's gonna tell you that, where is it? I can't find my shell. Yes. Even if you enter any argument, it's gonna tell you that no such file or directory. This is what you're gonna keep saying. And even if you enter a command, instead of it telling you command not found, it will tell you no such. So I'm entering the random thing here. It says that no such file or directory, and that's the requirement for the first one. Now let's tokenize our executable. Okay, so now how do we do that? And that's what I was trying to code over here. I'm gonna comment this out, and then I'm gonna come to the advanced shell, which tokenizes the argument. So I'm just gonna bring this to life. Great. So now let's code the one that tokenizes the commands, the argument. As usual, you want to include your shell.h. You want to create a function that executes. This is your parameter. It's a string. You create your child process and you fork it. You use the fork function to create a child process, the same process. If the child process is a negative one, it means it's an error. And then you exit with failure. Else, if the child process is 0, it means that it's success. So you want to execute the child process. Then the next thing you want to do is that create a string buffer that will hold a certain number of characters. The number of characters is your choice. You are going to create an integer that will count the number of characters in that buffer. Then the next thing you want to do is that you want to just create a string token, and that is where you're going to use the string tokenize function to tokenize whatever command will be given to the shell. Okay, you're going to say that while your token is not now, then you are going to count. You are going to use the integer variable that you created over here to count the details, the content of your string. Then you're also going to come and say that now you need to pass in the delimiter. I spoke to you guys about the delimiter. That is what determines what is going to be used to tokenize your string. So here in this case, we're using the string tokenize function. We are saying that the delimiter is a space. So anytime the shell encounters a space, it means it's moving to another argument, another command. We are going to use the args count, which you the integer variable which you declared over here. You are going to pass it as an index to the array. So this is an index array. This args array. So whatever the array is will determine at which point the string is being parsed. So we are doing string parsing. We are giving the array the indexes. So whatever index you are at currently, if it is now, then you are just going to. So I'm trying to say over here that if my argument, whatever index it is, the moment it's equal to now, that means that it's a now terminated argument. And I'm going to execute entire argument. So let's say my name is Leo. After mine there is a space. Name, after name there is a space. Is, after is there's a space. Then Leo, after Leo, now. So after Leo, nothing more is coming. So the moment you encounter that now at the end of the string, and basically what you are saying is that the command is over, so execute. Do you get it? My name is Leo. We have tokenized the string. We have divided all of them into several individual commands. Then we encountered the now terminating string. Okay, the moment you encounter the now, that means the string is over. So what do you want to do next? Execute the process. Okay, you can use a exec ve function or exec vp, exec whatever, the exec family of functions to execute that process. And then when you are done, you now want to print um, an error message if the process fails and exit with failure. Else, you're going to cause the parent process, just like we did in the first one. You cause the parent process to wait until the child process is done executing. Very simple. Very simple. Very simple. So that is how you tokenize your functions. So let's go in here and say that use the prompt to create a function that can tokenize your string to receive arguments. Create a readme, create a shell.h file, create a print function, create your entry point in the main.h, in the main source file. Create a function that can receive user input, right, with the fget function. Create a function that can show the prompt, the while loop, and create a function that can execute the prompt. Exec, child, fork. The parent process must wait till the child process is done executing. So child process equals to fork. There you come, execute. Parent process, wait. Simple. Then when you're done, you tokenize your string to receive argument. This is how you start your shell function. So from now to tomorrow, I don't expect you guys to sleep. I don't know how my day is gonna go like tomorrow. I expect you guys at least, if for nothing at all, go and try your hands on this one. If for nothing at all. What I'm gonna do is I'm gonna share these source code files with you. But you guys should, if you guys copy the same thing, you'll be flagged. Okay? But just to help you out, I'm gonna share this source files with you. These are source files that I wrote on my own. This is not from GitHub. This is not from anywhere. I sat down to code it on my own. I was asking myself that if I was to code a simple shell, how will I go about it? So these are things that I sat down. I was trying to code the entire task because I can't access the internet while I'm teaching. So I wanted to code the entire process so that at least I help you guys out. So I was saying that if I'm coding a simple shell, this is how I go about it. So this is something I coded on my own from scratch. So assuming all of you were not going to use it and only one person was going to use it, then that person is safe and won't be flagged. But since I'm going to share it to all of you, if all of you use it, it's going to end up being flagged. Okay? So what you want to do is that go into it and edit it, play with play with the functions. Hopefully, if I'm able to get time tomorrow, then we can go into the environment. You have to create a path, the env. You have to include a path to it. And then I think one of the things to said, you should do something. You've not handled advanced errors. You have not converted. You have not used the a to I, the ASCII to integer functions. You have not created any function. You guys listen to it. So right now, I've shown you the file organization. The same way I'm coding is the same way you're going to continue. It's not anything complicated. I've shown you the file organization. See that as I'm coding along, the functions that I'm trying to add to my shell is what was determining which file I was creating. So I wanted to create a function that receives user input. Now I've created user input to the C file. I wanted to create a function that reads the prompt. I've created a prompt to a C file. I wanted to create a function that executes a process. I created a execute.c file. That's what I've been. So now you're going to be reading additional tasks, and you are going to need to create more functions to be able to get a complete shell, right? So the more the functions you are supposed to create, the more your files are going to be. So right there, maybe you are supposed to create a functionality for your shell that's supposed to probably um, um, print a history. Then you are supposed to create a file. Or if you realize that certain functionalities are similar, then you can put those functionalities as functions in the same file. So for instance, I could have come and said that this function that displays the prompt, I can copy it instead of let me comment it, let me copy it and comment it out. Then I can rather go and put it in. Let me comment this out. I can rather go and put it in, since it's displaying the prompt. It's probably a friend to the execute function. So I can rather come here and say that let me put this display prompt function over here so that it will stay in the same file as this one. However, when I'm done in my main.h, no, shell.c file, I have to come and call the function. So you can put the function in other files, but you come into your main source file and call the functions over here. And as you are going on, your main shell.c file is also going to start increasing, beefing up. You're now probably going to have to include more macros. You're probably going to probably have to create a structure. You might want to use malloc to dynamically allocate memory. You might want to use um, what's argv, argc. We have not even handled command line arguments because we're not there yet. We have not even handled command line arguments, which is what? Command line arguments is when you give, so int main, when you give parameters to your main function. So let's say int main, and there's something like argc, then int argc, int char argv, which is actually a pointer, an array of strings. Then you're gonna say something like this. That's the vector. The vector in the argc is gonna be the vector count. Then you can now pass in command line arguments. You can say that print f, or since it's a custom print, you're gonna say that leo print, something like leo print percent s, which will print the vectors. Then I'm gonna say arg v. Maybe I'm printing the program itself, which is the first index. So I'll go like there, something like there. So these are command line arguments. We've not even come to, you're going to handle the command line arguments when now you need to handle additional arguments of your shell. So this is going to come in handy when you're handling advanced functionalities of your shell. So go and also read about command line arguments, and this is a prototype, the syntax for it. So I just probably gotta close this, and it gets advanced and advanced and more complex as you go on. But for now, don't even worry about command line argument yet. Go and start. At least you start the project. Start the project, because I don't even know why you guys haven't started. For now, you just go and start the project. If there are any questions, let me take it before we go.
Yeah, good evening. Can you hear me?
Yes, I can hear you.
Okay, thank you so much for your time. And I guess everybody really appreciates your effort and everything. I just have